Bismillahirrahmanirrahim. My name is Mariam Zubair and the topic of my department is based by technology. My roll number is 031. The topic of my presentation is heterogeneous equilibrium using the concept equilibrium constant. The introduction and the equilibrium constant is explained by my friend, and my topic is how to predict the concentration, how to predict the direction, and how to calculate the concentration. I will give an overview of the introduction and equilibrium constant. Homogeneous and heterogeneous equilibrium is a state of chemical equilibrium which depends upon the state of matter of the substance involved. Homogeneous involves the same phases, but heterogeneous involves different phases. There may be 2 or 3 states in heterogeneous equilibrium, and the position of the heterogeneous equilibrium does not depend on the amount of pure solid and pure liquid depends, and the substance may be solid, liquid, gas, or any solution. In calcium carbonate, it is an example of a heterogeneous compound. Calcium carbonate, when reacts, it changes into calcium oxide and carbon dioxide. Equilibrium constant, products divided by reactants, but sometimes the products are equal to 1 and sometimes the reactants are equal to 1. Concentrations are always at equilibrium and each concentration is raised to its stoichiometric coefficient. Equilibrium constant depends on the rate of constant, which in turn depends on the reaction and temperature, but sometimes it also depends on the pressure. There is no unit of equilibrium constant, and pure solids and pure liquids are excluded from equilibrium constant. A catalyst does not change the equilibrium constant, so it does not change equilibrium constant. Predicting the reaction, it's important to predict the direction of a reaction, so we must know that there should not be any blast in the lab. If we know the direction, we should know their path. When we deal with the reaction that are reversible in nature, it is important to figure out the direction of the reaction at a given instance. For example, in the formation of ammonia at a commercial scale from nitrogen and hydrogen, we need to optimize the process for efficient production. Thus, it is important to state the state of the reaction at any given instance. The given diagram said that if the equilibrium constant is greater than the reaction, then it moves forward, and if the reaction quotient is greater than the equilibrium constant, then it moves backward. Predicting the direction, how we can predict the direction of a reaction, how we know that it's moving forward or it's moving backward. We know by looking at the concentrations of reaction quotient and equilibrium constant. If the reaction coefficient is greater than the equilibrium constant, then it moves forward, or it moves backward, or it moves reverse in the direction of reactants. But if reaction quotient is greater than equilibrium constant, then it moves in forward direction, in that direction of products. But if they both are at equal rate, their concentration is equal, then the reaction is said to be at equilibrium. There is no net reaction occurs in any direction. If we compare Q and K, if Q is smaller than K, then there's too much product and we should increase the amount of products. But if Q is greater than K, then there are too much products and we should increase the amount of products and decrease the amount of reactants. Decrease the amount of products and increase the amount of reactants. Calculating equilibrium concentration. In a chemical reaction, when both the reactions and the products are in a concentration which does not change with time anymore, it is said to be in a state of equilibrium. In this state, the rate of forward reaction is same as the rate of backward reaction. For a reaction, if you know the initial concentration of the substance, you can calculate the equilibrium concentration. There are some steps for calculating equilibrium concentration. There are 6 steps. First of all, I have a problem. We have an example so that we should know that how to calculate the concentration. Problem statement: at 600 K, at 6 moles of PCl5 kept in 1 liter closed reaction vessel was allowed to attain equilibrium. We are required to find the composition of the mixture at equilibrium given that equilibrium constant for the reaction is 1. First of all, we write the balanced chemical equation for the reaction for the first step, and then we should convert the concentration in molarity, and the amount of PCl4 before the reaction is 6 mole and the volume of the reaction in the vessel is 1 liter. We should convert the concentrations in molarity, and if we convert in molarity it would be 6 moles. The step 3 is make to note the initial concentration and change in concentration for each substance on undergoing equilibrium. Change in the concentration is calculated by taking X as the concentration of one of the reactant and then finding out the concentration of other substance in term of X. The initial concentration will be 6 and the final concentration is 0. For example, at equilibrium 6 minus X, and we can assume that phosphate chloride is F, or PCl5 is X and Cl2 is also X. Using the equilibrium constant provided the problem statement, fill in the value of the equilibrium concentration in the equation. Note: while writing the concentration at equilibrium in the equation below, only those substances are taken into consideration whose concentration change probably. We have the formula and we put the values in the formula. Kc is equals to, the formula is the the values which are on the left side of the arrow, we say that they are a and b, and which are on the right side of the value, they are considered as c and d. So the formula is Kc is equal to c raised to power small c and d raised to power small d, and over a power small a and b power small b. So we put the value in the formula and we get Kc is equal to PCl3 Cl2 over PCl5. And 1, we have equilibrium constant as 1, and we can put the values and we get that 1 is equals to x square over 6 minus x. The step 5, solve for x. Now we have to know the value of x, so that we should know the value of equilibrium concentration. Since the concentration value cannot be negative, we take up the positive value of x. In other words, the value of x that makes chemical sense is taken. And when we solve this by factorization, we get 1x is equal to 2 and the other x is equal to minus 3, and we don't take the negative value, so x is equal to 2. Calculate the value of equilibrium concentration for each substance using the value of x. And when we put the value of x, when we take value of x is equals to 2, we get the reactants as 4m and products as 2m. And that's all from my side. If you have any question, you can ask in the comment section. Thank you. Allah Hafiz.